want us to talk about certain concepts under the multimeter. So we have this continuity mode. We have open circuit, and we have short circuit. So we have number 1, number 2, number 3. Continuity mode, open circuit, and short circuit. Now, under continuity mode, we are going to begin with continuity mode. So, under continuity mode, a certain point, which is, we are calling that point A, is linked to another point B via a continuous line. So continuity mode is coming from the English word continuous. There is no breakage in between, okay? So line A to line B will be considered continuous if there is no breakage in between, okay? So line A, B is continuous. So under continuity mode on your multimeter, you will turn your multimeter to a section that has something like this. Okay? It should be having something like this. Let me draw it properly. Something like this, something that is wavy like this, or something like a bell. Okay? Bell, or sometimes it is just a light that lights up whenever a circuit is complete. Okay, so you'll be having something like this, or rather at times you'll also be having a combination of this and something like this. So don't be surprised, they're all working the same. I said you can get a light on the multimeter, you can have something like a bell, you can have a wavy icon, or a wavy icon combined with the diode mode. So we are going to come to this diode mode later, but today. So this is continuity mode section where this one is the section where you turn your knob to. Remember yesterday we talked about the knob in the multimeter, that pointer. You turn it to this section on the multimeter. Could you do that, please? Yeah, we're there. So we want to find whether line A, B is continuous. And we already have our sample here. You have put your multimeter on continuity mode. So this one is multimeter usage. We want to find continuity mode. And we are having here our sample wire. So with our sample wire, this wire, you can identify the different wires by the coloring, okay? So you're having the white wire. Take hold of it. You're having the white wire, the white, the red, the black and green. So of course, white to white will be end to end, red to red, black to black, and of course green to continuity mode. So if you put your probe, now this is the point that I'm talking of, A, B. If you put your probes under continuity mode, and one probe should be on one side of the white, and the other probe should be on the opposite side of the white. Let me help you here. So let me hold it here like this. Now one probe, let's say, if you put your probe one should be on this side, and the other one should be on the opposite, white and white. So we are getting a beep, okay? We are getting a beep. So if you are getting a beep, that line is complete and there is continuity. Then we go to red, red. Red, red. Independently. Red, red. So there is continuity, and that line is complete. We go to black, black. Black, black is complete. We go to green, green. Green, green also is complete. So we have finished with the first section, which is continuous. The line is continuous. We say all of these lines are continuous. Okay? We go to open circuit. Or we can either go to open circuit, the second one, or short circuit. So we have two types of circuits that are remaining for you to understand what goes on. An open circuit. We're done with a complete circuit. The first one is a continuous or a complete circuit. The second one is, number 2, an open circuit. So what's an open circuit? What do you think an open circuit is? An open circuit. So for a continuity mode, I'll give you the notes later. An open, we have a complete circuit from point A to point B. Now let us take another reference, point B to point C. Now point B, C, there is a breakage in between. Okay? So you expect point B, C to be continuous. You are expecting, okay? You are expecting point B, C to be continuous, to have continuity. And you put here one probe, and you put here another probe. Then you do not get the beeping sound. You don't get the beeping sound. Okay? If you do not get the beeping sound, that means that this line, of course, there is a breakage in between. That is where continuity mode testing comes in. You test. Now, as unaangalia, you test which part, also you try to find out which part is causing the breakage in the circuit. So you might be having some voltage injected here, and you're expecting to get the same voltage on the other side. You are not getting it. So you are saying if you're getting voltage here, and there is somewhere in between the line that is missing, that circuit is open. Okay? And just go on to the next example, the next demonstration, which is an open circuit demonstration. We go this way. Broken 1 or 2. So I want you to test red and red. The same space. Make sure your multimeter is on. Red and red. It's okay. Green and green. Let us open it. Green and green. There is nothing. Okay? Black and black. There is nothing. White and white. There is nothing, you see? But red and red, there is a beep. So only red and red is complete. So if only red and red is complete, it means it is only the red line that is continuous. Then you have the black, white, and green here. We are using these ones as big examples. But when it comes to mobile phones, they are very, very minute tracks or rails. Very, very minute. But you have to understand it from a bigger perspective, okay? So that you know what to go about. So you now know what a continuous line is. Continuous. You know an open circuit. A continuous line is a complete line. A complete one. An open circuit is one that has a breakage in between, somewhere in between even though you are expecting it to be complete. So this one is an incomplete line. Okay, it's an interrupted line. It has an interruption. Interrupted line. Interrupted. Sorry, spelling is gone. Interrupted line. It has some interruption in between, okay? An interrupted line, an open circuit. A continuous line is a complete circuit. Complete. Okay? So you're getting a beep. So here you get a beep. Here you get, no? We're okay up to that point. Now we want to go to something a little confusing. A short circuit. Okay? A short three. A short circuit. Now with a short circuit, it's a little different because we're now having two or more tracks. Two or more different tracks. Now we have C, E, C, D, E, line E, F, line G, H. Okay? So these two lines, of course, they are continuous, but somehow or somewhere in between, one line has attached to another that is not supposed to. Okay? Now we're having two or more lines. You can even have three lines. I, J, K, J, K, L. You can have as many lines as possible. So these are the tracks that we find in electronics. Okay? The tracks that we find in electronics are called the circuits. Okay? A circuit, a complete track from one point to another, is a continuous one. Okay? So this one is a continuous line, is a complete. But this one, this line EFGH is a shorted line. Get it? Now let us put it in practicality. Let us put it in practicality so that you understand what we mean by a short circuit. So just say for instance, and you're having this, that you understand a continuous line, an open line, and a shorted line. So you're having black, black, okay, I've joined them there. I want you to take a test again. We begin. Red, red. Red, red. Okay. Now take red with any other color. Red with any other color. Okay. No, that one is an open circuit. That one. Okay. And we are good. So red is not supposed, by default, we know that red is not supposed to be linking with any other color but red, okay? Sorry, no, I'm joking.
kelele.
Tusifanye hii lesson vizuri. We go to another one. Nataka uelewe usipotee. Lakini umejua continuous open circuit. Sasa hii hata inatumika mpaka kwa stima kabisa, universal. Tuendelee. Let's proceed. Now I want you to take on white and any other color. Start with white and white. White and white. White. White and white is continuous. Of course, it is beeping, and you can see the multimeter is powering on. White with black. White and black. You see, it is beeping. Now let us take this one as our practical examples. We have white. Use the blue pen. I think you understand. We have white, black, red, and green. 1, 2, 3, 4. So, red and red. Red and red. Red and any other color. Okay, any other, just try all of them. Nothing. So red and red is a complete circuit. Sindio? There is no confusion. We try green and green. Nothing. Black and black. Black and white. Interchange this side to be black, the other side to be white. Black, white. You see? Now, I want you to understand something. You see, white and white is complete. Black and black is complete. Okay? But green and green is open. It's an open circuit. Now there's a problem here. Whenever you put a probe on white and another probe on the opposite white, it is okay, it's working, it's complete. But at the same time, if you put a probe on white and put on black, it's still complete. So if you put either, it does not matter whether you're putting it here or here, even if you put white and white. Now look at this one. Try white and white on black, white and black on this side only. White and black. You see? Try white and black on this side. You see? So any side that you put the black and white, it is continuous. Even though we know that these two lines are supposed to be independent of each other. Okay? We know the white line, white should only go to white, while black should correspondingly go to black. But here is a case or a scenario that the white wire is linking to the black, and it does not matter the direction that you are testing, they are all linking together. So this one is the one that we refer to as a shorted circuit. Worst case scenario is this way. You have understood here. But at the same time, we are having green, which is not connecting to green. So there is a breakage in between here. So the green is not linking up. So what do you do if you want to link the green together? You find the green color from this side and the other one from this side, put them together, okay? Then you would have completed the green circuit. You want to go back here. Let us go back to the white and black short circuit. Now we are having this one. In electronics, we'll be having rails, tracks. And these tracks might be like this. You see this line? We are assuming this is the white line. Let us assume the white line, and this is the black one. So this one is the white line, and this is the black one. Okay? In electronics now, on a circuit, on a motherboard circuit. Now, if this one should be carrying voltage, 5 volts, let's assume that this is the V-bus line. We'll come to understand what a V-bus line is. A V-bus line will have 5 volts. Okay? We are assuming then this line here is symbolized by something like that. Have you ever seen this symbol? This one is what we call GND. Can you guess what that is? That one is what we call ground. Ground, okay? This one is the negative side. So if by any chance this line links up with this, it will create what we call a short circuit. Get it? Yes. So we are having two lines. One is a positive and one is a negative. Positive, and this one is a negative. Okay? So we're having two lines. So if this one by any chance links up to this, we're going to create a short circuit. And how can that come? How can that come about? We are having two rails. A black, this one is a white, and black. We have used red and black, but it's okay. And this one is carrying 5 volts. This is what I've just said. And this one is, you see, on charging we have charging port, the 5-pin charging port. Having the 5-pin charging port, okay? And with the 5-pin charging port, it is just standard, or normally it is like this. One, now on charging, mobile phone charging, you are having 1, 2, 3, 4, 5. Okay? A 5-pin charging port. So line 1, 2, 3, 4, 5. If one of the lines on the farthest end is grounded, that one is ground. If you see this symbol, just understand it is GND, or the negative side. Is grounded. The very farthest end will be the positive side, which we also refer to as the thank you. Oh, we'll be having other things like the data miners, DM, DP, and all that. But at the moment, I want you to master these two lines. Okay? So the farthest end is GND, and this one is positive line. Okay? So you might be replacing a charging port. Okay? If you are replacing a charging port, the charging port has pins. I'm going to show you after this. The charging port has pins. And with those pins, you will have to connect them or to link them to the board, either the subboard or to the motherboard. So with those pins comes the polarity of the motherboard. Okay? So if this side is supposed to be positive, this side is supposed to be negative, the very far end, the opposite ends of each other. So that if you put your charger, there will be a flow of current in that order. It is going this way to return to that side. Okay? Not go too deep. So this one is the positive side, this one is the negative side of the charging port. Okay? So if this is the positive, this is the negative. And you are replacing this charging port, then by mistake or mistakenly, you put excess soldering wire or tin. Soldering wire is the one that you'll use to bond this charging port to the motherboard, okay, to the board itself or to the subboard. So if you put a lot of tin and by bad luck it joins with this one, so this line joins to this one, it will create what we call a short circuit. And that phone cannot charge. Okay? Now this is the simplest explanation of the short circuit at the entrance of the V-bus line. Okay? So if by any chance you put excess solder or tin, okay, while putting a charging port, you're going to create a short circuit. See, charging ports are made like this, with the charging pins by the end, the holding pins. And if I try to create a 3D image of a charging port like that, you'll have pins here. Of course, it will be like that. Let's assume it's like that. And you'll be having pins here. 1, 2, 3, 4, 5. Of course, this farthest end, the very end, this metallic part is GND. It will be grounded, GND. So if you have these ones as the positive, this one as the negative, 1, 2, 3, 4, 5. And while placing the charging port, you happen to link this positive to the nearest ground, negative. This port is going to have what we call a short. Okay? And it will not work. Okay? It will not work. Whenever you put your charger on a phone that is having a short, it will be heating up too much. That one just brings us to the first end of discussion concerning continuity, a continuous line, an open line, and a shorted line. So you're just going to do it practically, sasa. Yeah. Okay. Continuity, open line, shorted line, and a complete line. Okay? There is another topic that I want us to discuss or to introduce you to, which we are going to study. And that one is components of a mobile phone. And yesterday we tackled an inductor. We looked at a capacitor. And we found out how they are measured. Okay? So we looked into a capacitor, we looked into an inductor. Data.